Linear relations and putting everything we've learned together. So for the linear relations shown in this table below, we're going to look for the slope, the y-intercept, its equation, and we're going to decide whether or not it's a direct or a partial variation and reasons for our answers. So the first thing we have to ask ourselves is, how do I find the slope? I could draw a graph, or if the x values go up by 1 everywhere in the table, I can actually use my first differences to determine the slope. And since the x values do increase by 1, that's what we're going to do. And we're going to start with 3.5 take away 4, which is negative 0.5, and then 3 take away 3.5, and 2.5 take away 3, and 2 take away 2.5. Keeping in mind that the order that we subtract for first differences is very significant. It has to be the last y value, subtract the one before it, and so on. Because that sign that we get for the first differences is important. When it is the slope, it indicates the direction of the line. So right now, we know that the slope is negative 0.5, and we were asked to find the y-intercept. Well, the y-intercept isn't in the table. We need to have an x value of 0 in the table in order to find the y-intercept. So what could we do? So we don't actually know if this is a direct or a partial variation at this point in time. Because again, we don't know the y-intercept, and that's our criteria for deciding if something that's linear is direct or partial. We have a few options. We could plot the points and graph the line. Okay. We could continue our pattern in the table and go backward, but we don't want to do all of that. That's what we had to do the other day in order to find that equation. We know a lot more algebra now. So our algebraic toolkit is going to help us to figure out the equation of the line. Now we can remember that the equation of a line in slope y-intercept form is this one right here, y equals mx plus b, and we already know that m is negative 0.5, so we're going to put that point in. Now, if I think about the points on the line, I know that every point is going to satisfy that equation. So if I look at this, it doesn't matter which ordered pair I pick from this table of values to substitute in for x and y, it's going to help us to solve for b. So I'm going to pick the ordered pair 3, 4. So that means that where I see the x in the equation, right here, I'm going to put that 3 in right here for x, and I'm going to put that 4 in right there for y. And I have to solve my equation, and the first thing I have to realize is I'm going to have to multiply those two things together. Negative 0.5 times 3 is negative 1.5, and now I have a simple equation to solve. I need to get rid of this subtract 1.5 by adding 1.5 to each side, and I get my y-intercept is 5.5. The equation of the line is y equals negative 0.5x plus 5.5, and I can say it's a partial variation because the y-intercept is in fact not 0. Other thing I want to share with you today is some strategies for solving problems. So anything where we have to read to figure out what we're going to do. So there's a 3-step process, a countdown, if you will. We're going to read the question, then we're going to read and highlight all the key information, then read and underline what we're solving for in the units, so that we make sure before we even try to do the question, we have an idea of what we're looking for and how to answer it. Then we need to think about what tools or skills have I learned that are going to help me to solve this problem, and what's an appropriate way to model it. And step 1 in our blast-off strategy is to apply our knowledge and our skills and reflect on our solution. So if I look at this example here, it tells me it represents the activity in a person's bank account. Okay, it's bank account activity, not a lot of information given to me so far. If I look at it, I can get some information from it. I can see it's increasing. So that means as the number of weeks goes up, the balance is going up. First thing wants to know, does the graph indicate the person is depositing or withdrawing the money? Depositing is important, withdrawing, and justify. I want to know whether they're depositing or withdrawing. That's what the question's asking me, and it wants me to justify and give a reason. Let's go backwards. Since the balance is always getting bigger, that should tell me they're adding money to their account, correct? Because both variables are increasing. Okay. Part B asks, does the graph represent a positive or a negative correlation? Again, since both variables are increasing, it's a positive correlation. We have some written answers there. It's faster if I type it up ahead of time. Sorry, guys. So the graph indicates the person's depositing money because the total money in the bank account is increasing. Does the graph represent a positive or negative correlation? Positive, since the number of weeks and the total money in the bank are both increasing. So positive correlation, remember, both variables have to increase. What's the initial value in this bank account? Well, the initial value is right at week 0. Well, that's 0. Now, the rate of change, though, rate of change, there was a math word for that. What was that? That was slope. So I'm going from one nice point to another nice point. If I draw my arrows on, it helps me remember whether I'm getting bigger or smaller. So I need to know my scale on my vertical axes, and it looks like I'm going up by 100. So 1, 2, 3, 4. My rise is positive 400. And my run looks like I'm counting by 1 week at a time. So I went 1, 2 to the right, so that's positive 2. So my slope is, again, I write the words out, rise over run. It's, I went up $400 over 2 weeks. And you'll notice I put the units in this time because it's a rate of change. I'm changing the value in the bank account by $200 per week. And that is also the slope of the line. And that's just what this is showing you here. Now I can actually use that. I can use that information to describe the behavior of the function. It wants me to describe the behavior. That's what this question is asking me to do. And if I think about it, what is the behavior doing? The balance starts at 0. I have to talk about how it started and what it's doing. It starts at 0. It increases by $200 per week. Determine an algebraic rule. Remember, an algebraic rule is an equation. It relates the balance to the number of weekly deposits or withdrawals and the initial balance in the account. So ultimately, I'm looking for an equation. Okay. Remember, if I look at the graph, it was linear. So it's got to follow the slope y-intercept form of the line. So we have y equals mx plus b. Now m is the slope or the rate of change, which was 200. And b is the initial value or the y-intercept, which was 0. So really the equation is just the balance, b equals 200n, where n is the number of weeks you've invested your money. If I want to use the equation to determine the balance in the account after 12 weeks, so b equals 200n, that's important. I want the balance after 12 weeks. What am I solving for? I want the balance. Okay. Now what does this tell me? I'm looking for b equals, I don't know, and after 12 weeks, well, that tells me n is 12. And I've got my equation, b equals 200n. And remember what I said when you're substituting in, put brackets to make sure you don't forget anything, and that's 2400. And I need a nice sentence answer. So therefore, there is $2,400 in the bank after 12 weeks. Part G, use the equation b equals 200n to determine how long it will take to have a bank balance of $5,225. Okay, so I read it. Now I'm going to read it and highlight it. I've been kind of skimming over doing that because these are not long questions, but we really should get in the habit of reading 3 times. Use the equation b equals 200n to determine how long it will take to have a bank balance of $5,225. Let's read it again and focus on what am I solving for. Use the equation to determine how long it will take to have a bank balance of 5225. How long is what I'm solving for. That's my N. The bank balance is what I'm given. That's B. So again, I start with my equation, B equals 200N. And I have to substitute in what I know. And use my equation solving skills. I have to divide both sides by 200 to get N by itself. And we're just going to go to the next page so I don't have to get a calculator out. And it's 26.125. Now, I'm putting in money every week, not every day. So I can't have part of a week. In 26 weeks, I won't have $5,225. I'm going to have to wait until I hit 27 weeks in order to have that bank balance. And before class tomorrow, please do page 8, number 2 and 5.